Okay, now let's look at a pawn. Well, in the 8 cross 8, it has 4 different positions, which is symmetric across the remaining. There are 8 pawns in an 8 cross 8 board, and since due to the line of symmetry over the edge, you have 4 different distinct squares for a pawn. We'll call it P1, P2, P3, P4. And it converts to, after a certain steps, it converts to a queen, a bishop, a knight, or a rook. Therefore, one can say there are 2 choices. It can either move 1 step or 2 steps in the first move. So after a set of moves initially, it converts in the last square. So one can define Pi of n as 1, 2, 5 or Qi plus Kni plus Bi plus R of n minus 1 plus Qi plus Kni plus Bi plus R of n. For this is when n equal to 0, this is when n equal to 1, 2, 4, when this is n equal to 5, and this is when n is greater than or equal to 6. After 6 steps, it must convert. At the 5th step, it can convert. It converts either to the 4 pieces or it does not convert at all because it's 1 step behind. And before there's any chance to convert, it takes only 2 moves, depending on the starting move. This is your pawn. Now, let's for a high dimensional board, let's take a hyper cube, that is L cross L cross L k times, that is L power k, as your board, and let's look at the coordinate as board as a set of coordinates xi to xk belonging to nk power k, where nk is set of integers from 1 to k. K tuple of integers. Now let us introduce a piece called, I will be introducing 2 pieces called a j-Rook. Now a j-Rook is nothing but a piece that moves in k, exactly k components. Now in your standard definition, a 1 rook is your 2-dimensional regular rook. So in your 8x8 board, your 1 rook is your normal regular rook, and a 2 rook I will call, in a 2-dimensional board, a regular bishop. A 2 rook. So a j-rook, the valid move of a j-rook is, if you have a coordinate position of x1 to xk, then it moves to, then one of the valid moves is x1 plus minus m till xj plus minus m to xk, xj plus 1 to xk, where it moves in exactly m components with the direction varying but with a magnitude of m, where m is nothing but 1 to l minus 1. Let me correct this. Here it's NL, not NK. Numbers from 1 to L. Each xi belongs to one numbers from 1 to L. So it's NL power k, not NK, NL power k. So M belongs to 1 to L minus 1, N of L minus 1. So for example, take j equal to 3 and k equal to 4. Then a 3 rook moves in the following. Say you have x1, x2, x3, x4, and that moves to the y vector, and y vector belongs to the board. Say x1 plus minus m, x2 plus minus m, x3 plus minus m, comma x4. Then you have x1, x2 plus minus m, x3 plus minus m, x4 plus minus m, where exactly 3 of them you move in the you move with a magnitude of m in any direction. So you can move. So one of the valid moves will be x1 plus m, x2 minus m, x3 plus m, comma x4, or x1, x2 minus m, x3 minus m, x4 plus m. These are the valid moves for j equal to 3 and k equal to 4. For j equal to 2, k equal to 2, you have a bishop where x comma x1 comma x2 simply goes to x1 plus m, x2 minus m, or x1 plus m, x2 plus m, x1 minus m, x2 minus m, and x1 minus m, x2 plus m. These are the 4 ways for a bishop or a 2 rook to move. Now that's simply the same as a bishop. From here it moves forward diagonal, backward diagonal, or along this diagonal, where it's plus minus minus, plus plus, plus minus, and minus plus. So that is, this can be visualized in this way. Now a j queen. is a combination of all j-Rooks, j minus I rooks till 1 rooks. So for example, a 2 queen is 1 rook plus 2 rook. Your 2 queen is your regular queen in 8 cross 8. So a queen in the regular chessboard is nothing but a rook plus bishop. A rook plus bishop is a queen. So here 1 rook plus 2 rook is a 2 queen. And a 3 queen is nothing but 1 rook plus 2 rook plus 3 rook. So a j queen is when up to j components the piece can move. So x1 to xk, it can move in j component like a j rook, or it can move in j minus 1 component like a j minus 1 rook, or it can simply move in one component. So that is your j queen. Now we will look at the maximum moves for a j rook and the minimum moves for a j rook. Now a j rook from a corner, that is 1 1 1 1 1 k times how many ways it can move, how many ways a j rook can move in this situation. Well, you choose j components out of k, and then you multiply the magnitude. The magnitude can go from 1 to l minus 1. So you have kcj times l minus 1 ways a rook can move, a j rook can move from one of the corners. What about the center? Well, the center, let's assume L is even. In such a case, from the center, well, assume L is odd. Assume L is odd, then I would argue that you choose kcj components, then 2 power k times l minus 1 by 2. Why? The 2 power j, sorry. So 2 power j here because each component, each direction, the sign can vary from plus or minus. Plus or minus. So therefore, if I have say L equal to 7, then the center is 4. So 4, I have 5, 6, 7, or 1, 2, and 3. 3 forward and 3 backward. So I have for L equal to 7, I have kcj times 2 to the power j times 3. Because the magnitude can be 1, 2, or 3. So you have 3 here. And 2 power j because the center is equidistant from both the extremes. So I can move 3 steps forward or 3 steps backward. So you have kcj times 2 power j times the magnitude, the set of magnitudes. So what if, so here you have kcj times 2 power j times L minus 1 by 2. So what if L is even? If L is even, then then you simply assume that 1, 2, 3, 4, 5 and 6. Then you have two centers. Assume 3 is the center. Then it can move 2 steps forward, 2 steps back. So you have kcj times 2 power j times 2 times plus, if the magnitude is 3, then it can only move in one direction. If the magnitude is 3 when you are sitting in the third square, then you must move forward. If the magnitude is 3 and you're sitting in the fourth square, you must move backwards. So you have plus, because this is the center, you're talking about the center square. So you have kcj only times 1. So you have, so in the case of L equal to L is even, then you have kcj 2 power j L minus 2 by 2 plus kcj, which is again kcj 2 power j L minus 2 by 2 plus 1. So whether L is even or odd, we can simply write kcj times 2 power j floor of L minus 1 by 2, floor of this, the greatest integer function of this, plus 1 minus 1 plus minus 1 power L by 2. So if L is even, this sum is 1, and if L is odd, this becomes 0. And this becomes L minus 2 by 2 if L is even, and it becomes L minus 1 by 2 if L is odd. So therefore, this is true for all L, whether it's even or odd. Now, for a J queen, it's simply summation J I goes from 0 to K to J, kcj 2 power j L minus 1 j from 1, I would say. Yeah. There you go. This is the number of ways a J queen can move from the center. And from the corner, J equals 1 to I equals 1 to J, kcj L minus 1. Center, no, corner, center. So the lowest a j queen can move is in the corner, that is summation of kc j times l minus 1, and the maximum it can move is this.